We're going to start a new chapter. The chapter is on similarity. This is day 80. This is chapter number 15. Talking about similarity. You've seen congruency. If two triangles are congruent, which means they are of the same shape and same size. Okay. So if shape and size are same, then the two figures are said to be congruent. But about similarity, let's say for example, you have two rectangles. ABCD is one rectangle. XYZW is also a rectangle. When you talk about rectangles, the angles at the vertex are 90 each. All these angles are 90. And opposite sides are equal. Let's say for example, this is 6 centimeter, which means this is also 6 centimeter. These two sides are equal. And if this is 4 centimeter, this will also be 4 centimeter. So in a rectangle, opposite sides are equal and the vertex angles are 90. Now if you look at the other rectangle, it is smaller compared to this one. Okay. This is a bigger rectangle, this is a smaller rectangle. Okay. And the vertex angles here are also 90 degrees because it's a rectangle. Now these lengths are smaller than the 6 and the 4. Okay. So size is small. This size is big, this size is small. Okay. And the angles in both cases are same. Both figures are rectangles, which means the shape is the same. Both are rectangles, shape is same. And one figure is big, one figure is small. But the vertex angles in both of them are the same. All four angles are 90 degrees. Here also all four angles are 90 degrees. Therefore, these two figures are not congruent, but they are similar. So for similarity, you have to see the shape. Okay? Don't worry about the size. One can be big and the other one can be small. First thing that you have to check is whether the shapes are same. Both of them are rectangles, so shapes are same. And if their vertex angles are same, all are 90 degrees, here also all are 90 degrees, then these two figures are said to be similar. Okay? These are called similar figures. And when I say two figures are similar, similarity symbol is this one. Okay. This is the symbol used for similarity. For congruency, you have used this. That's the symbol used for congruency. But for similar figures, this is the symbol that is used. So these two figures are similar. You don't worry about the shape. Don't worry about the size. The only thing that you have to see is whether both have the same shape and if these angles are same. Okay, that's for a rectangle. Now coming to triangles, now there are different types of triangles. So just like that, by looking at two triangles, you cannot say, oh, both are triangles, therefore they have to be similar. No. Okay. So you will have to first check whether both of them are triangles and whether the corresponding angles are the same. In this case, the corresponding angles are like A and X are corresponding, B and Y are corresponding, C and Z are corresponding, and D and W are corresponding. These are corresponding angles. So if corresponding angles are equal, then the two figures are similar. Okay. So coming to triangles, say I have a bigger triangle and a smaller triangle. I have named the bigger triangle as ABC and the smaller triangle as X, Y and Z. Angle A, say, is 60 degrees. And angle B here is 70 degrees. And here, angle Y is 60 degrees. And angle Z is 50 degrees. Two triangles I have drawn. Okay. Both are triangles. So shape is okay. Both are triangles. The next thing that you have to check is to prove that these two triangles are similar. You have to see whether their corresponding angles are same. So in the first triangle, there is a 60 degree. This one is a 60. In the second one, there is also a 60. These two angles are corresponding angles, they are equal. Okay. But in the first triangle, the second angle is 70 degrees. There is no 70 at all in this. And the third angle here is not known. Here also the third angle is not known. Okay. Let's see how much is this third angle first of all. Sum of angles in a triangle is 180. So 60 and 70 together gives you 130. 130 and this will be 50 degrees. Total should be 180. This is 130. So from 180 take away 130, that will give you the 50. Okay. Now check and see whether the angles are same in both. Okay. There is a 60 in the first one, there is a 60 in the second one. That is A and Y are equal. These two become corresponding angles. There is a 50 degrees in the first one, there is a 50 degree in the second one. So the second corresponding angle is also equal. So both of them have 50 degrees. Both of them have 60 degrees. Both of them have 50 degrees. If the third angle here is 70, here also third angle must be 70. Why? Because the sum of angles in this triangle must be 180. 60 plus 50 is 110. So from 180, if you take away 110, this will be 70 degrees. Okay. So to prove that two triangles are similar, the first thing is you will see whether both of them are of the same shape. That is, are both triangles. Okay. So shapes are same, both are triangles. And the second thing that you have to check is whether their corresponding angles are equal. So in the first one there is a 60, second one also has a 60. The first one has a 50, the second one also has a 50. Okay. So two corresponding angles are equal. Automatically the third corresponding angle also becomes equal. So for a triangle, for two triangles, it is enough that you prove that two angles are equal. Automatically the third angle also becomes equal. So if this is 70, this has to be 70 degrees. It can't be something else because the sum gives you 180. Okay. So in this case, because the two angles are there, two corresponding angles are equal, these two triangles are said to be similar. Okay. So to prove that two triangles are similar, you have to check and see whether two corresponding angles are equal. Now, you know that these two triangles are similar. If you know that the two triangles are similar, then their corresponding sides are in proportion. Their corresponding angles are equal. Their corresponding sides are in proportion. Let's see what that is. Corresponding sides. Their corresponding sides are in proportion. Okay. Corresponding sides, I said. So you have to know which side corresponds to which one. Okay. For that, it's always better to draw both the triangles in the same way. Okay. So what I am going to do is, I am just going to draw the first triangle. Okay. And name it, that's A, B, C. Angles are A is 60, B is 70 and C is 50 degrees. I've done this. Now draw the second one. You don't have to bother about the size, nothing. Just draw a second triangle, but don't name it. Do the angle markings in the same position as you marked in the first one. The top angle here is 60 degrees because this also has a 60 degrees. 60 degrees. And the second angle that you know is 50 degrees. 50 degrees is this side, on the right side. So mark in the same position, 50 degrees. So what is 60 degrees in this triangle is Y. So now do the naming. This is Y. What is 50 degrees in the second one is Z. Therefore, Y, Z is already there, X is missing, so X is here. Now see, both of them, both are drawn in the same fashion. 60 is the top angle in both. 50 is the angle on the right side. So you know that these two triangles are similar, therefore their corresponding sides are in proportion. Now I'll tell you which are the corresponding sides. Now that they are drawn in the same way, corresponding sides are AB and XY are corresponding sides. This side and this side are corresponding. This side and this side are corresponding. And similarly, this side and this side are corresponding. You know that their corresponding sides are in proportion. So whatever are the corresponding sides, write proportionality for that. That is, ratio of the first sides is equal to ratio of the second sides is equal to ratio of the third side. Okay. So that's what I'm going to write. The proportionality is AB divided by, this is XY, must be equal to. Second one, AC corresponding to this is YZ divided by YZ will be equal to. Third side, BC is corresponding to XZ. So if two triangles are similar, then their corresponding sides are in proportion. This is the proportionality. All the corresponding ratios are equal. That's the proportionality that you can write if two triangles are similar. Okay. So these are few things that you have to know about similarity. We go to the exercise. This is exercise 15C, question number 2. In the adjoining figure, this is the figure given, AC is parallel to BD. AC is parallel to BD. These two sides are parallel. AC is 6, this much is 6. AE is 3, A to E is 3. EB is 4, EB is 4. ED is 4, ED is also 4. Calculate CE, this distance you have to find first, and also find BD, this distance. We'll do this first. Okay. Before we do this, look at this figure. You will see there are two triangles. First triangle is AEC, this one, AEC. Okay. And the second triangle is DEB, this triangle. First thing that you have to do is prove that these two triangles are similar. Now to prove that two triangles are similar, you have to prove that two corresponding angles are equal. Now you have to mark which are the angles which are equal. Okay. Let's say the most common angle which will be equal is this. They are called vertically opposite angles. So that's the first angle which is equal in both the triangles. This angle and this angle are equal. They are vertically opposite angles. The second angle is, you can see these two lines are parallel. If these two lines are parallel, then this angle and this angle will be equal. These two angles will be equal. They are called interior alternate angles. You can mark these or you can mark these. They are also interior alternate angles. Okay. So, first angle which was equal in these two triangles are these two because they are vertically opposite angles. Second one, so I have to put a different marking. For this I have put a single arc. Single arc I have used to mark the first angle. For the second one I will mark with a double arc. Angle A and angle B will be equal. These two angles are called interior alternate angles. So look at both the triangles. Are two angles equal? That is, first one is equal. The second one is also equal. Naturally, the third one also will be equal. We don't have to mark the third one. It is enough to prove that two angles are equal. Therefore, the two triangles are similar. But you have to first write the proof for similarity. Okay. These are the steps that you will write. First step. In triangle, first triangle is AEC, in triangle AEC and triangle DEB. You have to mention which are the two triangles you are proving to be similar. So these are the two triangles. In this, the first angle that is equal is this one, CAE. CAE. Wherever the angle is marked, that alphabet should be in the middle. Okay, when you name it, wherever the angle is marked, that alphabet should be in the middle. So C, A in the middle and then E. C, A, E. That's this one is equal to this one because both markings are same. So name is D, B, E. D, B, E. The angle is at B. So this alphabet should be in the middle. D, B, E. So these two angles are equal. Why these two angles are equal? Reason you are right. That is interior alternate angles. Second one. Second angle that is equal are these. To name them. For the first one, this alphabet should be in the middle. So AEC, angle AEC is equal to this one. E should be in the middle. DEB. DEB. Why these two angles are equal is they are called vertically opposite angles. Now that these two angles are equal, then you can immediately say that these two triangles are similar. Therefore, triangle AEC was the first triangle is similar, this similarity sign, to triangle DEB. You also have to write what property you are using for finding this similarity, for proving the similarity. Okay. For that, look at the marking here. This marking means an angle marking. So that's angle. For the second step also you use the same marking, which means this is also angle. So the property is angle, angle property. Angle, angle property. You can write AA property or AAA property because this is one angle which is equal. This and this is the second angle which is equal. This and this is the third angle equal. I said naturally the third one becomes equal. So you can write it as AAA property or you can write just AA property. Automatically the third angle becomes equal. Okay. So these two triangles are similar. Now you know that these two triangles are similar. Since the two triangles are similar, their corresponding sides are in proportion. So all their corresponding sides must be in proportion. Okay. For that, what I have done is, I am going to draw the two triangles separately. Normal way, just draw two triangles. You don't have to draw the triangles as they are present in this figure. Okay. So see how it is drawn. I have just drawn two normal triangles. Okay. Look at the first triangle and name it. Okay. So let's go to this figure. The first triangle is AEC. So I'll just name AEC. A, E and C. I have not named the second one. I have named only the first one. And let's see what are the angles that are marked in AEC, and let's do the same marking here. So in AEC, A was marked with a double arc, A was marked with a double arc, and E was marked with a single arc. E is marked with a single arc. I first named this and then looked at the figure and did the angle markings. A was marked with the double arc, E was marked with the single arc. Now, I have not named the second triangle. First I will do the angle markings in the same place as it is there in the first triangle. Okay. So, there is a double arc on top, so a double arc here, and single arc on the left hand side, a single arc. There is no angle marking here, so no angle marking. Now look at this in the actual figure. In the actual figure, the second triangle has a double arc at B. So the double arc must be at B. And the second triangle has a single angle marking at E. So this is E. BE is named. There is one more vertex that you have to name. So let's see what is the other vertex. BE already named, so the other vertex is D. So the vertex that is still left is D. Now look at both triangles. Both triangles are drawn in the same way. Therefore, now it's easy to find which are the corresponding sides. the corresponding sides are, for AE the corresponding side is BE, for AC the corresponding side is BD, and for EC the corresponding side is ED. Okay. So the proportionality is AC, okay, AC by BD is equal to, this side I have written first, AC by BD is equal to AE by BE is equal to CE by DE. Okay. So this is the proportionality that you get if you know the two triangles are similar. Okay. Now going to the question. The question is, see this, AC is 6, AE is 3, EB is 4, ED is 4. Calculate CE first. You find CE. Let's mark these. Okay. AC is 6. So AC is 6. That's 6 centimeter. Okay. Then you have AE is 3, EB is 4. AE is 3, EB is 4. And there's one more which is not. ED is also 4. ED is also 4. That's 4. The first question was you have to find CE. We will come to BD later. CE. Okay. Now, let's go to this proportionality. First question is you have to find CE. And CE is present in this ratio. CE is here. Okay. So, there are 3 ratios here. You can't take all 3 of them together. You will only take 2 of them at a time. Okay. So, CE is what is asked, therefore you have to take this ratio. Okay. And out of these 2, you have to take one of them, whichever is known. Let's check and see whether you know AC. You know AC, but you don't know BD. So, we cannot take this. Let's check this. You know AE and you know BE. Both are known. So this ratio has to be taken and this ratio has to be taken. These are the 2 ratios that you will equate. So AE by BE is equal to CE by DE. I have left out this. Okay. Put the values. AE is 3 by BE is 4 is equal to CE is what we are going to find divided by DE is also 4. Okay. You can simplify the 4. So CE is equal to 3 centimeter is the unit that was used in the question. That's the first part. The second part is you have to find BD. Let's go to this proportionality again. You have to find BD, and BD is present in this ratio. BD is here, and you have to use one of these, whichever is known. So this one is known, which is what we used previously also. So that one. And I'm leaving out this. So equate these two. AC by BD is equal to AE by BE. AC. AC's value. AC is 6 by BD is what you're going to find is equal to AE's value is 3 by BE's value is 4. You can simplify this. That becomes 2, that becomes 1. Multiply the 4 this side, that becomes 8 centimeter. BD goes that side is equal to BD. Okay. So BD's length is 8 centimeter. Your homework for today is exercise 15A. 15A, question number 12, only one question. And from exercise 15C, question number 1 and 3.